Hello, it's me, Mrs. Pinto, and we are going to be going over note section 1.4 today. So let's turn there now. Here it is. Simplifying square roots and the quadratic formula refresher. So hopefully you sort of remember how to simplify square roots. Some important information we want to remember is that the square root, if the number inside is like 10, that is actually made up of two different numbers being multiplied together, right? 2 and 5 in the case of 10. I'm putting it here as a and b, and that means that we can change it to the square root of a times the square root of b. And that way we can simplify perfect square parts. Typically I'll put those first, and then we'll leave the leftover part inside the radical. We can also do this with division because division is the same as multiplication, but like in the denominator, it's just a fraction that's being multiplied to another number. So in that case, if this is all together, we can write it as a over square root of b. And so I just love to put the little number letter refreshers up at the top of my page. And so if you find that helpful, you can do that too. Looking at number 1, I actually already know the square root of 225. It is 15. I just remembered. I'm going to need my calculator for this section of notes. So I'm going to go grab that. All right, I'm back. So I have a scientific calculator. If you do not have a calculator, I'm sure you have something like this bad boy. Yours is probably nicer. But you're going to need to open your phone all the way because you need to use more than just the standard. You need to use this side. And I mentioned that because I noticed that the directions say simplify, express each in the simplest radical form, and as a decimal approximation. And means both. Rounded to the nearest hundredths place, and hundredths is 2 decimal places. So I'm going to have 15, and then if I really wanted to be great, I'd do 15.00. Those are my 2 answers. All right, number 2. The negative there is on the outside, and then it's got square root of 169. I happen to know that's 13, and so it's negative 13. And then for the decimal places, negative 13.00. Number 3 has plus and minus, so this is actually representing 2 different numbers, positive square root of 44 and negative square root of 44. 44 has 4 in it as one of the factors, 4 times 11. And just like I said before, I would want to put the perfect square part first. That's why I wrote the 4 here. 11 is not a perfect square, and so that's why I've written it second. And that will just be helpful later on if you can write it that way. You don't have to. It'll just make it a little bit easier. So I know the square root of 4 is 2. So this is going to be plus and minus 2 rad 11. And that is considered the simplest radical form. That is the exact solution. Now, as it is now, it's been simplified, but I don't know exactly what number that is, and that's when I use my calculator. So in my calculator, the square root symbol is right next to the square, and it's in blue. So to access the blue, I have to hit second. So I hit second square root of 11, close parentheses. I'm going to hit enter, and it's square root of 11 being times by 2. So times 2, and I get 6.33. So when I round that, 6.3. Oh, no, it's 6.63. 633. So since there are threes, I round by not rounding up. And that's it. These are my two answers. Now, before I move on, I better verify that by checking with the original that it matches my decimal. And that's one way I can know that I simplified the radical correctly, is if the answer that I got matches in the calculator the original. So second square root of 44, the original number, and I got 6.633 again, which makes me happy. Now what about here? In your phone, if you have an iPhone at least, let's look at the order. So next to 1 over x, the next line in is square root. The little 2 is in the pocket. So if I hit it now, nothing happens. So I have to put in 44 first, then hit that button and I get out the answer. Or if I was checking my answer, I would put in 11 first. So I really have to tell it the PEMDAS. Start with the one inside the parentheses or inside the exponent. And then I times that by 2 and I get 6.63. So we need to test our answers. Being that you guys are at home, you're probably more likely to be on your phone. So I'll try to go through both. All right, number 4. Number 4, okay, that's 0.04. And that's 2 decimal places. So I think that this is 0.2 times 0.2. Where am I going to check that? In my calculator. I'm just more comfortable with this kind of calculator though. And I get 0.04. So then, yep, that's the answer. Negative 0.2 is simplest radical form. And then negative 0.20, that's just me being like, yeah, 2 decimal places, very specifically following the directions. All right, number 5, 40. Look at how I'm going to do it this time. Off to the side. 4 times 10, right? I picked the 4 because it's a square root. If you don't end up picking the right number at the very beginning, you're going to look for the factor tree. So let's say I didn't know it was 4 and 10. I'm like, oh, it's 2 and 20. And then 20 is 2 and 10. And 10 is 2 and 5. So what I look for then is the numbers that don't have branches off of them, I'll cross those ones out. They're not part of the prime factorization. And I'm looking for pairs since it's a square root. So there's a pair of 2s. So that pair of 2s comes out. And then left inside, it just comes out as 1, 2 though. I see the 2 and the 5. 2 times 5 is 10. And so those will be left behind. Don't forget the negative sign. So that's another way you could have done it. And to our decimal approximation, I'm going to go, it's easier and faster here. 10 square root times 2. I get 6.324, so that's going to be 6.32. And it's negative. And then testing that with the original 40 square root, confirmed. So I'm going to do simplify number 6 just quietly. And I want you to try to simplify the numerator. And then after you simplify the numerator, we're going to simplify the denominator. And that's what we're going to do on this next row. So 27. So you can see I've simplified the numerator, and now I'm going to simplify the like terms. And by that, I just mean I cannot simplify a number that's outside of a radical with a number inside a radical. And I can't simplify a number inside a radical with a number that is not also inside the radical. And that's because of PEMDAS, right? That rad 3, it has an exponent on it technically. It's in parentheses. Remember that square root is half power. So instead I'm going to simplify these two. Please circle them. And 3 divided by 6 is 1/2. So I divide really the top and bottom, and I get 1, and I get 2, and I get negative square root of 3 over 2. Now, I want my decimal approximation, so 3 square root, and then I hit divided by 2, and I get 0.866. So I have to round that up to 7. 0.87. Testing the original 27 square root divided by 6, and I get the same thing. What am I forgetting? The negative sign. And so these are my two final answers. Great. 1,000, that's 100. Oops. 100 times 10. Hopefully you know the square root of 100. So I've got 10 red 10 in the numerator divided by 5. Just these two divide. Circle the ones that you're dividing together. I've got 2 red 10. And then taking the 10 square root times by 2. I got 6.324, which is odd. I feel like I got that number just a moment ago. Negative 6.32. And then let's test the ridge. Divided by 5. Perfect. It's going great. All right. Number 8. 20,000. Well, I know that 10,000 is 100 times 100. And 10, 1, 2, 3 times 2. So I thought about it because there's 4 zeros. There's going to be 100 divided by 16. And then 100 divided by 16. So 100 divided by 4 is 25. But 25 is not divisible by 4. So I'm going to divide the top and the bottom by 4. So divided by 4. And I'm going to get 25 rad 2 over 4. And that's as simplified as it gets. So let's see. In my calculator, I start with the 2, the rad 2, times that by 25, and then divide that whole answer by 4. And I got 8.38. So 8.38. No, I keep missing that 10th place, 8.838. And so I'm going to have to round that 3 to a 4. And better confirm before I circle it, 20,000 square root divided by 16. Perfect. So I really like these that I can easily test them with my calculator pretty quickly. All right, let's check out number 9. 9 and 10 are so fun because look at this. 4 and 9, square root of 4, square root of 9. I can use that rule from the beginning, and you know the square root of 4. It's 2. You know the square root of 9. It's 3. So 2/3 is our simplified answer, but remember that's not the decimal. I know that it's 0.6 repeating, but I think because they said hundredths, I'm going to just go 0.67. It's been rounded now to the hundredths place. All right, number 10. Ooh, you try it. Just going to do it quietly. You try it at the same time as me. All All right, check my work. Was I on the same page? Yeah, that one was easy. 49 is a perfect square. So this was a lot of excellent work. We're looking at refreshing our memory here. And the whole basis of this is so that we can simplify problems like 11, 12, 13, 14, and 15. And these are similar to what the answers from the quadratic formula look like. And we want to be able to, number one, understand what this number is, simplify it completely, especially because, you know, on those standardized tests, they'll have this answer and then they'll have a different answer, like, and they'll say select all that apply. So you want to have that in your mind. And also just know how to correctly simplify a fraction. So looking at number 11, I see the 360 inside the radical. I'm going to start inside the radical, and then I'm going to distribute the divide by 2 to each part. So here's part 1, and here's part 2, and I'm going to do that for all of these. So with 360, I know that's 36 times 10, and fortunately, 36 is a perfect square. So that comes to 8 plus 6 rad 10. And then the whole thing is divided by 2, but watch how I write it. Divided by 2 and divided by 2. So I've split that divided by 2 to each part. It's very clear that we have to divide this and get 4. But it's less clear with the 6 rad 10. Fortunately, we just practiced that. So I'm going to divide the 6 by the 2, but not the 10. We always leave what's inside the radical just as it is, unless it comes out perfectly. So that's going to be 3 rad 10. This is our final simplified radical answer right here. What was really nice is that the 2 went in evenly to the 8 and the 6. I think it is usually best to write the answer as a fraction with a single denominator. And so we'll look at some instances where it's just hard to know the best way to write the answer. And so I'll leave it to you, because as long as they're both correct, I'm actually curious to find out what your feedback is about what looks more simplified. I'm curious. Okay, so now I've got to figure out the calculator of that. So I'm going to start with the answer that I've circled. I'm going to start with the 10, rad 10, times that by 3, and then add 4 to that, so plus 4. It's weird because I'm going backwards in the problem, but I am following PEMDAS. So I got 13.486. It was 8.6, so I'm going to round that 8 up to a 9. And then let's double check that by starting inside the radical with the original. So 360 in the radical, plus 8, enter, okay? And now divide that whole thing by 2. And I got 13.486, yay. All right. So you can see the work here. We simplify the radical, then we distribute the denominator to both parts and simplify, and we check our answers. Let me confirm that these are the answers, not the 8 divided by 2. All right, so number 12, we're going to do the same thing. 192, that's a tricky one. So I'm going to use my calculator and divide that by 2. 192 divided by 2. Oops, I messed it up somehow. 96. 96 isn't a perfect square. I'm going to do 192 divided by 3. 192 divided by 3 is 64. 64 is 8 times 8, so 64 times 3. And I usually do that just starting with 2, 3, 4, going down the line with larger numbers to see if there's a perfect square inside of it. So this is going to give me 6 minus 8 rad 3 divided by 30 divided by 30. And so from here, you're going to simplify. Remember, it's never going to cancel out completely. The answer is never going to be 0. So that even though the 6 divides into the 30 completely, we leave it as a 1. That's 1/5 minus, but the 8 and the 30, they don't go in as nicely. They are both divisible by 2, but that's it. So this is going to be 4 rad 3 over 15. And see how now they have different denominators? So that's where I was talking about, is this the best way? Or should I have just divided them both by 2? And that would have given me the answer. So 6 divided by 2, 3, and then 15 minus 4 rad 3. And then I could write it as one big fraction. And so to me, I'm like, which looks better? I think this looks best. I don't know. Now let's find the decimal answer. So since I circled that one, I'm going to do the decimal for that one. I'm going to start with the rad 3. So 3 in the radical times by 4, enter, divide by 15, enter. And then, oh my gosh, now I need to turn this to minus. Then I'm going to add, and I'm going to put it in parentheses, 1 divided by 5, close parentheses, hit enter. And I got negative 0.26. I hope you're following along in your calculator. So let's go back to the original. There I'm going to do 192 square root. It's negative. Then I'm going to do plus 6, enter, and then divide by 30. I got negative 0.26. So nice. And then if you had already known that 1/5 was just 0.2, that was good. Good of you. All right. These next ones, I'm just going to do quietly. You try to follow along and see if you can get the same answers. All right. So if you're still working, you can pause and watch these, rewind and watch later. But I got all of these finished. I really liked number 15 because it was the perfect square in the radical. So these were really super fun. I loved refreshing my memory. And then keep in mind, we've written it in exact form and then the approximation, because as you saw, all of these radicals, they're technically called irrational numbers. That just means their decimal never repeats. Like we had 2/3 here at number 9. 2/3 is a rational number because the decimal repeats. But these radicals are irrational numbers. It's such a tongue twister. So the radicals are irrational because the decimal never repeats. So, okay. We've got a little bit more, so if you need to take a break, you can pause and come back to this. This section is pretty long. Now we're going to move on to the quadratic formula and using our skills that we kind of just refreshed our memory about. I'm going to switch over to pink if I can. And yeah, excellent. So the quadratic formula is this equation or expression, x equals negative b plus or minus the square root of something all divided by 2a. So you can see it kind of is familiar to those 11 through 15 problems in format. The challenge is what's inside the radical is a kind of gnarly expression, b squared minus 4ac. So we're looking at 1, 2, 3, 4, 5 operations. A quadratic equation looks like this. Okay, so an equation has all the numbers in it, and it's 0 equals ax squared plus bx plus c. And of course, you're like, oh, the letters that are in the formula. Right. And those letters will, of course, be numbers. And so this is just a big substitution problem where you're substituting in the numbers and doing the calculations. So here are the equations. So something super important to note is that the a quadratic equation is only a quadratic equation if it's in this format where it's equal to 0. It could be equal to y, and we would replace y with 0 and say that we're solving for when y is 0. But otherwise, if it's not equal to 0, we have to manipulate the equation so that it is equal to 0 with addition or subtraction. And typically, it's nice to write it in standard form, which, remember, that's descending order, in power order, right? Who's the most powerful? They come first. The next most powerful, etc. So that's why it's x squared, x, and then no variable. So looking at 16 and 17, I see that they're already in the correct form because they're equal to 0. 18 is not, but I can easily move the 25. 19 is in the correct format. 20 and 21, they both need a little bit of manipulation. So we've got 6 problems here, and then we're done. So let's work through these. We're going to solve the quadratic equation using the quadratic formula, and then write it in simplest radical form and as a decimal. All right, let's work it out. I know that A is 1, B is -3, and C is 2. So I've got opposite of B, 3, plus or minus the square root of B squared, which is 9, minus 4, and then you've got to use the parentheses here, times 1 times 2, all divided by 2 times 1. Okay, so now I'm going to do the multiplication right here. That's the next step. And I do my side work, 9 minus. I know that it's minus because there are no other signs. 4 times 2 is 8. 9 minus 8 is 1. So do we know the square root of 1? Yes, we do. It's just 1. So I've got 3 plus 1 over 2 and 3 minus 1 over 2. I split that plus or minus. So 3 plus 1 is 4. 4 over 2 is 2. 3 minus 1 is 2. 2 divided by 2 is 1. Because these are not in simplest, these aren't radicals, I'm just going to circle the answers and move on. 17. Opposite of b, 1 plus or minus the square root of b squared, 1 minus 4 times 2 times negative 3, all divided by 2a, which is 4 in this case. So now I'm going to do my side work. It's going to be 1 and it's going to be plus because there are two negative signs. 4 times 2 is 8. 8 times 3 is 24. 1 plus 24 is 25. Oh my gosh, I like this one. Square root of 25 is 5. 1 plus 5 over 4. 1 minus 5 over 4. 1 plus 5 is 6. So let's write that as the fraction 3 over 2. And 1 minus 5 is negative 4, so negative 1. Since these are both rational numbers, I'm not going to write them as a decimal. I'm only going to do that if there's a radical. Okay, number 18. I need to make this equal to 0 here, so hopefully you thought of it. Let's add 25 to both sides of the equation. And now it's ready to go. So opposite of b, plus or minus b squared, minus 4 times 1 times 25. Ooh, that 25 looks funky. All divided by 2a, so in this case just 2. All right, the side work. So it's going to be 100 minus, only one negative sign. Oh my gosh, it's 100 minus 100. That's 0. Okay, square root of 0. It's 0. It's 0. So when I'm adding 0 and subtracting 0, this one is awesome. This just all cancels out, and I've got 10 over 2. This only has one solution. All the other problems had two solutions, so this one is very special because it only has one. That only happens when we get the plus or minus 0 because of the nature of 0. All right, 19. 19 is funky. It's not in power order. I'm just going to rewrite it in power order and watch what I do. Negative 4x squared. But how many x's are there? 0 x's. And then plus 81. Now that 81 is positive. It's the 4 that's negative. And this really helps me set up the problem. So this one is probably not going to have just one solution. Let's take a look. Opposite of b, still 0, plus or minus. Square root of 0 squared, which is still 0, but then minus 4 times a times c. All divided by 2a, which is in this case negative 8. So interesting. So this part is 0. It's just going to make it a little bit easier. All right, my side work. It'll be 0 plus, oh my gosh, 16 times 81. I don't know what that is, so I'm going to use my calculator. $12.96. And 16 and 81 are both perfect squares, so it's going to be 4 times 9, 36. So I'm going to get plus or minus 36 divided by 8. And dividing those both by 4, I'm going to get 9 over 2. And so I still have the plus and minus because it belongs to this side. And those are my two answers, 9 over 2 and negative 9 over 2. It's probably better to write it that way for you guys. 9 over 2 and negative 9 over 2. Or you could write them both as 4.5. All right, hopefully you're on a roll. Do you feel confident to try 20, the hard one, by yourself? Maybe you do. I'm going to do something and you solve it simultaneously, and we'll see that we get the same answer. Okay, hopefully you got 2/3 and -1/2 like I did. Or you can check to see if you're on the right track and finish up. I'm going to go right on to number 21. 21, I've just got to do one little baby step. And now it's ready to go. For a second there, I was hoping that I would have a GCF. And then I could divide everything by that GCF to make the work a little bit easier, but not this time. So feel free to solve this one. We've got large numbers, so it's going to be a little bit more challenging. And my side work, it's still going to be minus. Oh my gosh, how annoying. 4 times 3 times 10 is 120. Oh my gosh, this is the first one that's going to be a little bit hard. Well, it's going to use the radical simplification skills that we were just looking at. So I did 144 minus 120 and got 24. And 24 is 4 times 6. You know what I'm saying? So the square root of 4, I've got -12 plus or minus 2 rad 6. And then distributing the 6 because I have those coefficients, and I'm going to get -2 plus or minus, dividing those, square root of 6 still, but over 3. And oh, we still want to divide that 6 and 3, but we cannot. This is the final answer, and I like this answer. Let's find out the decimal solution for this. So I'm doing my square root of 6, enter, divided by 3, enter. Oh my gosh, remember we've got to get 2 answers. So -2 plus rad 6 over 3 and -2 minus rad 6 divided by 3. So I can't remember which one I just did. So I'm going to start over. Okay. Starting with the 6. 6 in the square root divided by 3. I'm going to make it negative. And then I'm going to subtract 2. I got -2.816. So I'm going to round that to -2.82. For this one, 6 in the radical divided by 3 minus 2. And I got -1. It's 183, so 18. And those are my other two solutions. And so that does it for your notes today. I hope this was very informative and fun, and I wish you all the best on your homework, and see you next time.